right, we are still working on the geometry final review worksheet, the review that does not have multiple choice answers. I'm on number 8. They tell us here that we have a trapezoid. I am thinking that they have misused this symbol. I think they are using it as a quadrilateral. But we use that symbol as a parallelogram, but it's not. It's a trapezoid. They give us side AB right here is parallel to side CD. And they give us this side length and this side length, these angle measures. And they want us to find the area in the perimeter. Well, you know, to find the perimeter, you have to know all side lengths. And to find the area is 1/2. Let's see what the area is. We have the formula sheet here for a trapezoid. It is 1/2 the sum of the bases times the height. So we have 1/2 the sum of the bases plus the height. Now remember, the height is the distance between the two bases. So the distance between these two bases, you could draw the perpendicular measurement several places. I'm going to place it right here at vertex A because I believe I'm going to be able to use the information that we know about parallel lines from this angle right here, which is 45, and this angle right here, which we just created, is 90. I believe that's going to give us a 45-degree angle, and that's important because it's going to help us find this side length right here. Not the whole side length, but from here to here. So let's name this point right here. How about let's call it E. So we're going to be able to find the length of DE, or at least we know the length of DE is the same as the height, and that's going to be important information. Now, the other thing that we want to do is I want to connect A to C. And the reason that I want to connect A to C is because I know this angle up here is 60. And since this angle up here is 60 and these two side lengths are the same, that makes this an isosceles triangle. That means that this angle right here and this angle right here are base angles of an isosceles triangle, which means they're congruent. So you take 180, which is how many degrees there are in a triangle, take away the 60 that's in the vertex angle, that leaves you 120. Take half of that, and this one is 60, and this one is 60. Now we know that we have an equilateral triangle, which means this side over here is 12. That's helpful because we know now that we have a right triangle right here. And I believe we're going to be able to show that this angle right here is 60. There's a couple of ways we can do that. We originally had, here's AB and DC, and they were cut by this transversal right here. Cut by that transversal. Well, we know that these two lines right here are parallel. These are same side interior angles. So this one and this one have to equal 180. So I know that's 120. Now, that may help, except I drew a line right here, and there's really no way for me to know that I just halved that angle. So I'm going to have to go back now and use still these parallel lines, but the transversal that I drew in right here, this is AC. This is AC right here. I drew in AC. Well, this angle we found to be 60 degrees. That means that this angle right here is going to be 60 degrees by alternate interior angles. So I do know that this is a 60-degree angle. So now I have a 30-60 triangle, and I know the hypotenuse. And if I know the hypotenuse, remember The hypotenuse is 2x, the short leg is x, and the long leg is x square roots of 3. So that means that if the hypotenuse is 2x and it's equal to 12, that means x must be 6. So this piece, EC right here, is 6. And if this piece is 6, then that means this piece right here is 6 square roots of 3. So this piece right here is also going to be 6 square roots of 3, because remember it's a 45-45 triangle. And now this 45-45 triangle has two legs that are 6 square roots of 3. That means the hypotenuse is going to be 6 square roots of 3 times the square root of 2. Because remember, for a 45-45, let's go look at that formula. For a 45-45, see, the formula is x root 2, and each one of these side lengths right here was 6 square roots of 3. So I am got to take the 6 square roots of 3 and multiply it by the square root of 2, and that's going to be 6 square roots of 6. Okay, so to finish this problem, I've got to add all of the sides up. I've got this side right here, which is going to be 6 plus 6 square roots of 3. I can't add them together. This is going to be 12. So I've got 6 plus 6 square roots of 3 plus 12 plus 12 plus this one right here is 6 square roots of 6. So I can add the like terms together. So that's 24 and 6, that's 30, plus 6 square roots of 3 plus 6 square roots of 6. And unless they want me to round, that's going to be my final answer. I can approximate, and that would be 30 plus, and 6 square roots of 3 is about 10.4. 10.4. And then 6 square roots of 6 is about 14.7. So if I add those two together, I'm adding them together, so it's taking me so long. The final answer is going to be about 55.1. Now, just so you know, I went back and used the exact decimal values. I didn't just round didn't just add the one decimal place. I went back and used the exact value. So it may not come out to be exactly that if you just add what I have written down. But let's see what the answer key says for number 8. For number 8, they have the perimeter in exact form, 30 plus 6 square roots of 3 plus 6 square roots of 6. Okay, so now let's go back and finish the area. I completely forgot about it, to be quite honest with you. The area, we have all the pieces that we need, though. The area, let's do it in a different color right here. So the area was 1/2 times 12 plus 6 plus 6 square roots of 3. And then that is multiplied by, let's see if I can't get rid of this. And that's got to be multiplied by the height, which is 6 square roots of 3. So I'm going to take half of the 6, that's 3 square roots of 3, times, what is that, 18 plus 6 square roots of 3. Looks like I have to distribute 18 times 3 is 54. So that's 54 square roots of 3, because this times this plus this times this is going to be 18 times 3. 3 times 6 is 18. The square root of 3 times the square root of 3 is 3. So 18 times 3 is 54. So 54 plus 54 square roots of 3. That is the area. And this was the perimeter. And I believe that's what the answer key showed. Area right there. So, yes, you should leave it in exact form until the very end, and then you should change it to a decimal, only if the multiple choice problems, are in decimals. If this was a multiple choice question, we would be able to see exactly what we want. Very involved. Look at all of that. You had to do a lot. You had to draw in lines. You had to know your 30-60 formulas. You had to know about isosceles triangles. But this is the kind of problem that you're going to see on the test. So it's not just going to be, this test is not just, one process problems. It's going to be, they're mostly are going to be multi-process problems. All right, so I'm going to change the color of my pen to work over here. Here it looks like I have a geometric mean problem because I have a right triangle, and from the right angle I drew an altitude. So I know that this is the leg. The leg is the geometric mean. So I'm going to start my geometric mean formula. The leg is a geometric mean to the whole hypotenuse. This is the piece that I don't know, so I'm going to call that x. To the whole hypotenuse. And the whole hypotenuse is going to be 16 plus x. And then the segment of the triangle that's attached to the leg that we know. So this is going to be x. Looks like this is going to be a quadratic one. So we're going to cross multiply. We're going to get x squared plus 16x is equal to 15 times 15, I believe, is 225. And then we're going to have to factor or use the quadratic formula or something. And so I don't waste your time, I am going to go ahead. Oh no, I'm going to go look and see if what the answer is, because I can see real quickly if it's going to be a nice number that will factor. Okay, so it should factor. CD should be 12. So now I'm going to continue to factor that. If you were doing this on the test, you could also take this problem and graph it and see if it crosses the x-axis. Well, let's just do that right now. I'll go over here and I will grab a screen on the Desmos calculator. And this is just to see if this will factor or not. I'm going to do x squared, I believe it was plus 16x. And then if I subtract that 225 from both sides. Now, this will tell me there's my 9 and 25. So I know that 9 and negative 25, it's actually going to be negative 9 and positive 25, are the two numbers that are going to multiply together to give me 225, and they will subtract to give me 16. So it will factor. So now I'm going to go back and I'm going to say, okay, x squared plus 16x minus 225 is equal to 0. And that's going to be x plus 25, and that's going to be x minus 9. And I know that it has to be that way because these two have to be since that's a negative, the signs have to be different. This number is positive, so that means the bigger of the two numbers has to be positive. Now, we use the zero product property to tell us that x plus 25 has to be equal to 0, or x minus 9 has to equal to 0, because when you multiply two numbers together and you get 0 as an answer, one of those numbers has to be 0. So the answer is either negative 25 or the answer is positive 9. X is a distance, so it can't be a negative value. So we know that this thing right here is 9. And the other thing that they wanted us to do was find BD. Oh, we did find BD. And now they want us to find CD. Okay, so CD is the altitude right here, the altitude. We can also look at it as the height of this right triangle right here, the distance between the vertex and if we call this the base. Altitude or height, either one, is the geometric mean. So we set up our ratio, our proportion is the geometric mean to the two pieces. Okay, so that's going to be h squared equals 9 times 16 is 144. And you take the square root of both sides and we get h is 12. Okay, so we found CD to be 12. And now that we want the area, I know that here's the base and I know the height. I could go ahead and find this measurement right here and do 1/2 base times height right there, but I already know that measurement. 9 and 16 is 25, so I'm going to do 1/2 12 times 9 plus 16, that's 25, right? So 1/2 12 times 25 is going to be 125. I don't know. I don't trust my mental math. I'm trying to see how much money I have if I have 6 quarters. No, it should be 150, I believe. I'm going to make sure. Yeah, it should be 150. Still have the eraser selected. Okay, so the area, I found all the missing pieces and the area is 150. So CD was 12, BD was 9, and the area is 150. Let's go check that real quick. 12, 9, 150. All right, I'm going to go ahead and stop this video because I don't see anymore how long it is. I think it's long enough.